$13.5 billion years ago, the Big Bang. The Big Bang produced a lot of stuff, and some of it we would recognize: protons, electrons, and neutrons. The protons and electrons and neutrons immediately assembled to form hydrogen. Another billion years later, and stars had formed. The stars are big giant balls of hydrogen. Inside of the star, the hydrogens got pushed together, and two hydrogens turned into helium, giving off energy. And then almost simultaneously, 4 heliums got pushed together to form oxygen, again giving off energy. I think it's reasonable to start our exploration of oxygen by pointing out that oxygen is number 4 in the universe. It's hydrogen number 1, helium number 2, and then actually the distant third is oxygen. From the Big Bang, let's move forward 13.5 billion years to the present, and the little planet that we call home. The planet Earth is perhaps the densest object in the solar system. It's made mostly of iron, but the outside layer of it, just the very outside of it, is much lighter material. The crust of the Earth is mostly made out of oxygen. And you say, but the crust of the Earth is made out of rocks. Rocks are mostly made out of oxygen. The world of chemistry sometimes can be divided into the world of anions and the world of cations. The cations tend to be metals, but the anion side of it is an oxygen-related thing. The anions, these are the negative charges, are like silicates and phosphates and nitrates in the hydroxyl group in water. So oxygen is the number 1 element on the crust of the Earth. A very close second is silicone. Silicone? Silicone. So you could make the argument that the crust of the Earth is made out of silicate, which is silicone and oxygen. So the 21st century, human beings on the planet Earth, everybody talks about water. We're looking for water on the moon and looking for water on Mars and looking for water on the moons of the big planets. Water? Okay. Water is number 1. The planet Earth is in the Goldilocks zone of liquid water. So water is the number 1. But elemental oxygen is a very close second. Oxygen is like non-existent in the universe. Pure oxygen reacts with everything. And to have pure elemental oxygen, like oxygen, O2 gas, non-existent, certainly non-existent in our solar system, and very, very, very rare in the universe as a whole. In fact, it might be possible to speculate that if you find oxygen, you've got life, because there's nothing else that forms it. When I was in 7th grade, they'd say things like, "We live in the bottom of a poisonous atmosphere of oxygen." And I'd be like, "Poisonous atmosphere of oxygen? I don't seem to be having any problems." Poisonous atmosphere of oxygen, if you put that word on a chemical level, then suddenly it makes sense. A poisonous atmosphere of oxygen. If you take something that will react, if it has the possibility of reacting, and you put it on the surface of the Earth, in our atmosphere of oxygen, in sunlight is very potent radiation, it will react. So the third rock from the sun is all about water, but it's also about elemental oxygen. And of course, the oxygen in our atmosphere came from water. So there's this cycle of oxygen, water, carbon dioxide, and carbohydrates. It's all pretty amazing.